Hey guys, I want to talk to you for a second about multiplying and dividing rational expressions. I want you to keep in mind multiplying and dividing fractions as I go through it. So say, like I wanted to divide 2/5 times 15/4. What's the idea? Usually just to cross simplify, right? So 2 goes into 4 two times, 5 goes into 15 three times, so that I'm really left with 1 times 3, which gives me 3, over 1 times 2, which gives me 2. Now we're going to actually be doing rational expressions, so we're going to have variables in the numerator and denominator, but it's essentially the same idea. My steps for you guys are pretty simple, just 2 steps, but my tip is to always rewrite the expressions in standard form first, meaning go in order from least to greatest according to degree. If I had x plus 2x squared plus 5, I would rewrite it as 2x squared plus x plus 5 before I try to do anything. So I want it in standard form before I try to factor all the expressions and then cross simplify any common factors. That's really all it comes down to. Factor all the expressions in the numerators and denominators, and then cross simplify any common factors. So for example, say I had something like x squared minus 4x minus 21 over 3x squared minus 147 times x squared plus 14x plus 49 over 3x squared plus 30x plus 63. There's a lot of long expressions here. And so I want to just factor everything. Factor the numerator on the left, the denominator on the left, the numerator on the right, the denominator on the right. In the first case, x squared minus 4x minus 21, a is 1. So I can just factor, asking myself what two numbers multiply to negative 21 and add up to negative 4. It should be negative 7 and positive 3. So the numerator on the left factors to be x minus 7, x plus 3. They multiply to negative 21 and add to negative 4. The denominator on the left, well, I don't see that it's a difference, but it's not a difference of squares. But I do see that 3 comes out of each of those. So for now, I'll just factor the 3 out. That leaves me with x squared minus 3 goes into 147 49 times. Then I factor the numerator on the left. On the right, x squared plus 14x plus 49 factors to be x plus 7 times x plus 7. And then I could try to factor this expression on the right, 3x squared plus 30x plus 63, but I see that a 3 comes out of the denominator as well there. So then I'm left with x squared plus 10x plus 21. I'd much rather try to factor this because a is 1. I don't have to do the AC method. So let me keep factoring. The top on the left is done. It's x minus 7, x plus 3. But now, along with the 3, I see that x squared minus 49 factors to be x plus 7, x minus 7. It's a difference of squares, so they factor into conjugates. In the numerator, I have x plus 7 still. The 3 is already factored out in the denominator, but the two numbers that multiply to 21, positive 21, and add up to 10 are positive 3 and positive 7. So I factored everything, and now rather than have to multiply it all out, I get to cross simplify any common factors, meaning there's an x plus 3 here that cancels out with this x plus 3 down below. So remember, you're cross simplifying. They have to match from top to bottom. So in this case, I don't even have to go all the way across. The x minus 7 and the x minus 7, those cancel out as well. I see that, hey, there's an x plus 7 that cancels out with an x plus 7. And then I see that this x plus 7 cancels out with this x plus 7. So a lot of stuff canceled out. If everything cancels out in the numerator, then all you're left with is a 1, just the same as before. On bottom, I still have a 3 times a 3, so that gives me 9. That's actually a super, super nice case. Think about it. I have this very huge, complicated expression with variables everywhere. And when I multiply it, all the variables cancel out. I get 1/9. But I can't cancel over addition and subtraction. Like these x squares, they don't cancel. The x squares don't cancel. The x's don't cancel. No way. I have to factor everything first and then cross simplify any common factors. All right, so let me show you another one. One where actually I can just factor it all right away. Say I have something like x squared minus 6 minus 27. I have to ask myself what two numbers multiply to negative 27 and add to negative 6. I think that's negative 9 and positive 3. They multiply to negative 27 and add to negative 6, so it factors to be x minus 9x plus 3. This shortcut only works when a equals 1. Keep that in mind. The bottom is a difference of squares, x squared and 81. That factors to be x plus 9, x minus 9. There's a formula for difference of squares. That's what we're using. Then what happens if I have x squared plus 18x plus 81? The two numbers that multiply to 81 but add up to 18 are positive 9 and positive 9. The two numbers that multiply to 27 and add up to 12 are positive 9 and positive 3. So I factored everything. You should go through, check your factoring, make sure it works in all these cases. I see then again that the x minus 9's cross cancel, the x plus 9's cross cancel. But then I also see, hey, there's this x plus 9 that crosses out with this x plus 9, and there's this x plus 3 that cancels out with this x plus 3. Everything canceled out top to bottom. This is a really, really nice example. It just gives you one. But let me show you an example where maybe they don't all cancel out, and also it's not even in standard form. Say I want you to multiply 18x minus 12x squared over 9x squared plus 12x plus 4 times 6x squared plus 13x plus 6 all over 4x squared minus 9. What you notice is everywhere except for this top left-hand numerator, the numerator on the left-hand side, is in standard form. This one isn't. So I would take a second and rewrite it as negative 12x squared plus 18x over 9x squared plus 12x plus 4. The rest of the stuff is fine, so I'll leave it as 6x squared plus 13x plus 6 over 4x squared minus 9. What you'll notice in this example is it's a little more difficult to factor. Why? Because I can't factor anything out of this denominator. I can't factor anything out of this numerator. So I just have to use the AC method to factor. Since the leading term is negative in the numerator up top on the left, I'll factor out not only a 6x, but a negative 6x to leave me with 2x minus 3. You should practice factoring 9x squared plus 12x plus 4. You can go back to previous videos to see how to factor it, but in this case it factors to be 3x plus 2 times 3x plus 2. I've just factored so many of those that I can do it in my head. But I think you should practice factoring by grouping. That's the key to this whole thing. 6x squared plus 13x plus 6. That also might be a little bit more difficult to factor out. You just got to try a few different combinations and check factoring by grouping. But if you just factor 6x squared plus 13x plus 12, you're looking for the two numbers that multiply to 36, add up to 13 so that you can make change with them. And then when you make change, you factor by grouping. So that gives me that this factors into 3x plus 2, 2x plus 3. Again, just practice factoring. Once you get it down, you'll see that this is what it factors to be. Then the 4x squared minus 9, that's a difference of squares. It factors to be 2x plus 3, 2x minus 3. So just like before, I'm factoring everything. Notice I could have gone back up to the beginning and I would have factored out a 6x. The problem is that that wouldn't have been in standard form, and that would leave me with 3x minus 2 instead of 2x minus 3. The benefit of having it in standard form, since this one was in standard form down here as well, they cancel out exactly. So you should always write it in standard form to see what cancels out. Now, there are some other terms that cross-simplify. A 3x plus 2 cross-simplifies with this 3x plus 2. And again, a 2x plus 3 cancels with a 2x plus 3. But this time, not everything canceled out. So I'm just left with negative 6x over 3x plus 2. And that's the best I can do. So again, I recommend you write it in standard form and then factor everything. cancel top to bottom. Whatever cancels out, the 2x minus 3's cancels out, the 3x plus 2's cancel out, and the 2x plus 3's cancel out. But I'm still left with, on the numerator, a 6x, a negative 6x, and a 3x plus 2. All right, so if you're not okay with factoring, go back and practice a ton of factoring because it's going to be a big deal all week. So give it a shot. I'll see you guys later.